Hi, this is Nimla Rednam. In this video, we are going to discuss the third exercise from the chapter Factorization from NCERT textbook class 8. Now here in this exercise, we are dealing with division of algebraic expressions. Now if you remember the 8th chapter algebraic expressions and identities, there we looked at multiplication. We left out division there. Now here we are dealing with division because now that you know how to factorize a given algebraic expression, you will be able to write a given algebraic expression as a product of factors. Now once you have done that, you will be able to divide any two given algebraic expressions simply by cancelling out the common factors in the numerator and denominator. That is the method we will be using for division in this exercise. So we are going to look at division of a polynomial by a monomial, monomial by another monomial, polynomial by another monomial, and polynomial by polynomial. In each of these cases, wherever you have a polynomial, that is an algebraic expression, what you will be doing is first factorize it, write it as a product of factors, and then simply cancelling out the common factors is what we will be doing, right? So let's look at the sums in the exercise. So here in the first exercise, as you can see, we are given a monomial in both numerator and denominator. Since it is a monomial, there is nothing for me to factorize as such, right? I'm simply directly going to write down 28 x power 4 by 56 x, right? So what are the common factors here? You can see that 28 into 2 will give you 56, right? And then you have 4x in the numerator and 1x in the denominator. So if 1x gets cancelled, I'll be left with x cubed. So answer is x cubed by 2. This is how you will be doing division of a monomial with another monomial, right? And then I have minus 36 y cube by 9 y square. Okay, so 9 table, you know that 9 into 4 is going to give you 36, and then you have 2 y's here and 3 y's here. So if I cancel 2 y's, I'm left with y. So the minus sign 4 into y. That is my answer. Now in the third question I have 66p q square r cube by 11q r square, right? So now I have 1 q I can cancel, 2 r's I can cancel, right? So I have 6 p q r, right? So that is my answer. Next I have 34 x cube y cube z cube by 51 x y square z cube, right? So if you look at 17 table, 17 2s is 34, 17 3s is 51, and 1x gets cancelled, I have x square left, and 2 y's get cancelled, I have y left, and z cube and z cube get cancelled. So I have 2 by 3 x square y, right? Next I have 12 a power 8 b power 8 by minus 6 a power 6 b power 4. So 6 2s is 12. 6 a's get cancelled, I'm left with a square. 4 b's get cancelled, I'm left with b power 4. So I have minus 2 a square b power 4. That is your first sum. In the second sum, you have a polynomial which is getting divided by a monomial. So like I said, the first step is to factorize the numerator, right? So now here I have a binomial, and we have already discussed a different number of ways of factorizing a given algebraic expression. Now here, because I have two terms and I see that x is common, I'm going to take x outside the bracket. I'm left with 5x minus 6, right? So now I will do the division. X into 5x minus 6. I cannot factorize 5x minus 6 any further, so I'll leave it like that. X gets cancelled. So what am I left with? 1/3 of 5x minus 6. So that's my answer, right? So now here again we are going to look at the numerator first, try to factorize it. Now you can see that there are three terms here, and y power 4 is common in these three terms. So let us take y power 4 outside the bracket, and then I have 3y power 4 minus 4y square plus 5, correct? Now can I factorize this any further? You will see that you will not be able to factorize it any further, right? In using your identity, or if you use your identity, you could factorize this, but then you will get irrational coefficients. So let us see if this is going to be enough, because if the denominator is, as you can see in this case, the denominator is getting cancelled with the y power 4. So I can leave it at that, right? Y power 4 is getting cancelled, and my answer is 3y power 4 minus 4y square plus 5. So that's my answer. Next, I have to factorize this, where I have three terms, and you can see that x square is common, y square is common, and z square is common. So if I take x square, y square, z square outside the bracket, I am left with x plus y plus z, right? Divided by 4x square, y square, z square. Okay, so I have 4 2's. So I'm left with 2 times of x plus y plus z. That's my answer. Now here again I have to factorize the numerator. X is common. Let's take it out and see what we have. I have x square plus 2x plus 3 divided by 2x, right? Now here x square plus 2x plus 3, it has three terms, and we can actually factorize it, because like I said, we might be able to factorize it, but the only thing is here, this x is anyway getting cancelled and the division purpose is served, so you don't have to worry about it, right? So this is your fourth bit. Next we have two terms over here. I know that p cube is common and q cube is common. Inside the bracket, I'm going to have q cube minus p cube, right? Which can further be factorized. You have an identity for that, which will immediately give you the factorization and product of one linear and one quadratic term over here. But since my denominator is already taken care of, this can be given as the answer, right? So this is your second sum. In the third sum, we have similar such questions. Let us quickly factorize the numerator. 5 is common, so 5 into 2x minus 5 divided by 5, that is equal to 2x minus 5. Here I have again 5 is common, 2x minus 5 divided by 2x minus 5. Now 2x minus 5 is a monomial that is getting cancelled, and the answer is 5. Okay. Now here you can see that in this binomial 3 is common, right? So I'm going to bring that outside the bracket, right? So I'm going to have 10y into 3 times of 2y plus 7, right, by 5 times of 2y plus 7. Now this monomial 2y plus 7 is common. I'll cancel it. 5 2s is 10. So now I have 6y left. So that is my answer. Right? Here you can see that 3 is common. So bring 3 outside the bracket. Z minus 8. Now the denominator also has z minus 8. Right? So cancel off z minus 8 and you have 1x, 1y cancelled, right? 9 3s is 27. So that is getting cancelled. So I have the answer x1. Next, here in the denominator, I have already, it is already factorized. Even the numerator is already factorized, except of course there is a 3 common here and there is a 5 common here. We'll take that out. 96abc into 3 times a minus 4 into 5 times b minus 6 by 144 times a minus 4 into b minus 6. You can immediately see that you have a minus 4 common, b minus 6 common. So you can cancel that. And next, you know that in the 12 table, you're going to have these two, right? So I have 12 12s is 144, 12 8s is 96, right? And then 3 4s, 4 2s. So I have 10 A, B, C. That is my answer. Next question. Here, this is already factorized. I cannot factorize it any further. So simply have to cancel out the common factors. That will give me the final answer. 2x plus 1 is the common factor. If I cancel that, I will have 5 times of 3x plus 5. That's it. Next question. I have, again this is factorized. I cannot factorize this any further, both the numerator and the denominator. So I'll simply write it down as they have given it. 13x y minus 4. So here you can see that y minus 4 is common. I can cancel that. X I can cancel. 13 ones, 13 twos. Right? So the answer is going to be 2y times x plus 5. Right? Now here, again this is already factorized. So I simply have to carefully take down the question and cancel the common terms. That is that. P, Q, Q plus R, R plus P. So you can see that R plus P is common, Q plus R is common, right? P and Q are common, right? And then I have 52 into 2 is 104. So that gives me half R P plus Q. That is the answer. Now here you can see that y plus 4 is linear, so I can leave it like that. Whereas this is quadratic, right? Now this is quadratic and this we have to check whether it can be factorized or not, correct? And however, you'll see that in the denominator you have y plus 4. That's it. There's no other factor. 5, of course, the numerical factor, which gets cancelled, and y plus 4 is getting cancelled. So like I said earlier, since the denominator is taken care of, you need not worry about factorizing this. You can leave the answer as this, right? Next year again, they have already factorized it for us. So there's no need to do any factorization. Simply note down the question and cancel the common terms. That will give you the answer x plus 2 into x plus 3. That's your answer. Next exercise, here you can see that this is a quadratic and it has 3 terms. So you know that you have to factorize it, right? And let us see. Now, whenever you have 3 terms, like I said, we'll first thing we'll do is check if the identity is going to help us. If the identity has to help, y square is perfect square, good enough, but 10 is not a perfect square, so the identity is not going to help. Next, what we will do is try to write the constant term as product of two factors whose sum is the middle term. 1 into 10 will not work because I have 7. 2 into 5 is going to work, right? So I'm going to split the middle term and write it as 2y plus 5y plus 10. Now I'm going to pair this and do the factorization. So I have y into y plus 2 plus 5 into y plus 2. Now you can see that y plus 2 is common. Therefore, the factorization is nothing but y plus 2 into y plus 5. Now this divided by y plus 5. I can cancel y plus 5 and write the answer as y plus 2. That is how you have to solve it. Now here again I have 3 terms and clearly identity is not going to work because I have minus 32. So let us check. How can I write minus 32? 1 into 32 clearly will not work. Plus 1 into minus 32 or minus 1 into plus 32. Both are not going to work. 2 into 16. If I have minus 16, you know that the sum is minus 14. So that is going to work. So I have m square plus 2m minus 16m minus 32. Now you consider these as two pairs for whom I am going to write m into m plus 2 minus 16 into m plus 2, right? Which is nothing but m minus 16 into m plus 2. Now when I divide it by m plus 2, I can cancel this and I'm going to get m minus 16. So that's the answer. Next question I have, the numerator has 3 terms and clearly 5 is common. I'll take it outside so that I'll have clarity of how to find p square minus 5p plus 4, right? So 4 can be written as 1 into 4, plus 5 won't help. I want minus 5. So I'll write it as minus 1 into minus 4. So here I'm going to write the factorization directly. P minus 1 into P minus 4. That's my factorization, right? Divided by P minus 1. This gets cancelled and my answer is 5 times of P minus 4. So that's the answer. Right. Next I have, again I have a trinomial. I have minus 16. Okay, 1 into 16 is not going to help. 2 into 8 is going to help me. I need a plus sign, plus 6. So I will put minus 2, right? So I'm going to write the factorization directly. I have z minus 2 into z plus 8. Okay, that will give me the factorized form. Now I'm going to cancel out the common factors. Y is common, z plus 8 is common, and 2 ones, 2 twos. So I have 2z into z minus 2. That is the answer. Next I have, now this is the identity that we have looked at. A square minus b square is equal to a plus b into a minus b, right? So divided by 2p into p plus q. P gets cancelled, p plus q gets cancelled, and I have 5 by 2 times q into p minus q. So that's the answer. Now here you can see that there are two terms, there's a minus sign, and immediately you need to check if these are perfect squares or not. You can see that these are perfect squares. This is nothing but 3x whole square and this is nothing but 4y whole square. Okay, so a square minus b square will give you a plus b into a minus b, right? Divided by 4xy into 3x plus 4y. Okay, so 3x plus 4y is common. 4 3s is 12. X gets cancelled. Y also gets cancelled. And so I have 3 times of 3x minus 4y. That is my answer. Next question, last question. I have 50y square minus 98, right? So here it is because there are two terms separated by a minus sign, you can check a square minus b square, but you will see that 50y square is not a perfect square, neither is 98. So how do we proceed here? And clearly we have to be very sure whether I can factorize this or not, because I have a 5y plus 7 term in the denominator. Maybe it gets cancelled if we are able to factorize the numerator. So you need to be very sure that this is actually we can factorize it into linear terms or not, right? Two linear terms. So here clearly a square minus b square is not working in this form. What if you were to take 2 outside the bracket? Then what will happen? You have 25y square here and you have 49 here. So now it is clearly a square minus b square. This is 5y whole square and this is 7 square. So now you can directly write into 2 into a plus b, which is 5y plus 7, into a minus b, which is 5y minus 7, right? And then write down the denominator 5y plus 7. Okay, now cancel 5y plus 7 and you have 2y's here and 3y's here, so 1y is left, and you have 2 into 13 and 13 into 3. So the answer is 3y times 5y minus 7. So that will give you the answer. So with this, we finish the topic factorization, and in the next video, I'll be starting the next topic, which is introduction to graphs, and that is the last topic left in the NCERT textbook of class 8.